I just did something awesome. I created a distributed denial of service attack out of Amazon Web Services by design. So I have this friend who runs this website for a school that does registration for events. So all these parents come and register their kids on this website. And he came to me, he goes, I wish there was a way to really, kick the tires on this and performance test it, because we're going to have an event coming up it's a first come, first serve, and a whole bunch, thousands of parents are going to come and try and register their kids for this event. And then he said, I wish there was a way I could test, make sure it works. So I was like, let me look. And so I did a little Googling and came across this thing called Bees with Machine Guns. I'm serious, go Google it. Bees with Machine Guns by the Chicago Tribune, actually a newspaper, created this Python script that allows you to integrate into Amazon Web Services and spin up a whole bunch of micro instances, that's the bees, and go out from different source IP addresses and attack, that's the machine guns, the website. Now it's not malicious, it's just sending a flood of requests to say, hey, I want your website, I want your website, I want your website. So I run this thing and I say, give me 100 instances, and it comes back and says, oh, Amazon Web Services only allows you up to 20 without applying for an upgrade. I'm like, okay, give me 20 instances and go and attack that website with 500,000 requests all at once. And I'm watching on the screen as it spins up all the instances. It actually shows, arming the bees. Whoever created this script is great with their little lingo, and they're firing their machine guns. And so my friend is like, oh, I see it, all these different source addresses, and it's keeping up, and so it gives you a report at the end. It was awesome. I love doing that kind of stuff. So anyway, after I finished that, I started thinking, I'm like, and the first thing I did was go to and apply for an upgrade on my account so I can run more instances than the limit of 20 out of the box. But I started thinking, I wonder if I should have used a medium instance, because would that give me a little more network throughput, or maybe a large, because you figure it's only a few dollars. I think I did that whole denial of service attack for less than $1. I'm like, okay, I'll throw $5 at it and have some beefy servers. And then I thought, I wonder if I should have used some spot instances. So all these questions come to mind. That's the whole topic of this nugget. Instance types and performance implications. Here are your do I know this already questions, so pause the video, read through the questions. If you know the answers to all these, you're probably good and can move on to the next video in the series. Otherwise, let's get started. AWS is a kind of ambassador of technology goodness. It's my new phrase for them, because you can do so much cool stuff with AWS. But do you want to know what's at the core of AWS awesomeness? I mean, what has fueled AWS to be the massive worldwide entity they are today? It's the pricing model. Think about it. You've long since been able to get a server in the cloud. For decades that's been going on, where I can pay somebody and get a virtual server or a physical server, and it's $150 a month. That's my server, and I get this much resources to it. Well, AWS was the first one to come along and say, you know what? How about a no-commit model? How about you come use a server for an hour and pay us a nickel? And it's kind of a disposable server. Totally changed the paradigm of the world from this vertical growth by bigger, better, faster servers to this massive horde of minions. I'm thinking of my bees with machine guns now. This massive horde of minions of disposable servers that really don't hold anything that's not replicated somewhere else, that you can come, you can use, you can destroy, and you pay for what you use. That is the paradigm shift. That's what changed the whole industry in terms of hosted devices. Understanding the EC2 pricing models is critical, not just for the exam, but for the real world as well, because this is really what dictates how much you pay for your AWS. So there is another series at CBT Nuggets called AWS Essentials, and in there I unpack this over about a half hour and get out the spreadsheets and network bandwidth and storage and put it all together. That's not what I'm going to do here. Here I'm just going to give you an overview of the model so you have the tools you need to pick the right model for your environment. It all starts with on-demand instances. On-demand instances are the most expensive model, the simplest model, but the most expensive because you're paying for the non-commit. Meaning this is the one that you can go and get a T2 medium, let's just say, and I'll explain what that is on the next slide, it's just a cocktail of CPU, memory, resources all combined together in this little bucket that we call T2 medium, and they might sell that to you for 15 cents an hour, right? I don't even know what the prices is currently on a medium instance. Use it for a couple hours, turn it off, and you pay Amazon 30 cents for using a server in the cloud, right? Very simple design. Let me actually take that down to the spot instance pricing, which is still less complex than the reserved. Spot instance is taking that same model and putting it up for bid. Essentially, Amazon Web Services has extra resources all the time. They don't run their data centers at 100% capacity, so they put all the extra CPU memory resources up for auction to the highest bidder. The beauty of this is you can get machines on the cheap. You can say that same medium instance over here might cost me 3 cents an hour, but the drawback is it's always up for bid. You have the maximum bid. Let's say you bid 15 cents an hour is your maximum. Somebody comes and outbids you, and bam, immediately your instance terminates, and those resources go to the next person. So a complete non-guarantee. Some people play a dangerous game with spot instances. They just say, you know what, I'm going to set my maximum to $100 an hour, right, in the spot instance world, so that I can run at this, and I can guarantee I can kind of give myself a level of stability here, because nobody's going to outbid me at $100 an hour, because, well, good grief, why would they do that? Well, here's the danger of that game. It only takes a few people doing that before you start, and you actually can see it. If you look at spot instance historic pricing, you'll actually see, it stays really low, and all of a sudden you have these peaks where it's like, wham, for a few hours, then bam, back down, really low, wham, back down. Because essentially this is non-guaranteed resources. If people start eating them up in the on-demand world, or a data center becomes more saturated, a couple people playing this game causes this to shoot way up. Not only are people now getting their instances terminated that never thought they would be, because they kind of did this for a level of stability, so it could cause instability in their infrastructure, but also they may end up losing all of the financial gains they got from using spot instances. So if you talk to anybody who's serious about Amazon Web Services, they'll be like, nah, that's not a game I want to play. Reserved instance pricing is the one that you want to play. That gives you a level of stability, but also gives you a cost benefit. Essentially, all reserved instance pricing does is take you to a level of commit. Amazon will say, I want you to commit from anywhere to one, I think right now the 1 or 3 years is the current commit intervals. And that you say, I'm going to run that server in the cloud for a year. There will be an upfront cost. So you will pay, let's just say, $100 upfront in exchange for a much lower hourly rate that you're paying for that server. You do still pay hourly for that server, but it's going to be much lower, and you end up saving a bundle. Matter of fact, if you go to the Amazon Web Services, again, if you go back to that AWS Essentials series, there's a whole chart there showing, well, if you run it for this much amount of time and this much amount of time, you save 60% off of the normal on-demand pricing. So the gains are significant if you're willing to commit to Amazon Web Services. One thing worth mentioning, and this is probably the most confusing piece of reserve instances. This all makes sense, right? Commit for a few years, you pay an upfront cost for a much less hourly rate, to where in the end you end up ahead. The thing that makes it confusing is the light, medium, and heavy instance type, right? Heavy, if I could put that in there. Essentially, all it means is how often do you plan to run these servers? See, Amazon Web Services, as I said at the very beginning of this, was the game-changing model where people can use servers, terminate them, bring them back up, terminate them, all that kind of stuff, and they only pay for what they use. Well, this is what this comes into, is essentially how often do you plan on your server running, right? If you run it maybe 30% of the time, then you're going to get a better pricing model using the light instance, right, than you would buying a heavy. A heavy instance is one that you would be running 100% of the time, all the time, and you get a much better price for doing that, but you pay a lot more upfront to do it. So essentially this, when you go for a reserved instance, you choose an interval, you choose an instance type, which we're going to talk about in just a moment, the medium, large, extra large, all that kind of stuff, and you choose a utilization. So if you aren't sure, usually the best bet is heavy. Now, the other thing I want to make sure I mention at this is a framework. It's a framework for billing, not a specific instance. So for instance, I could be running an EC2 instance that's a web server under this reserved instance pricing, terminate that EC2 instance, bring up another one that's now a database server, right? And it goes and uses that reserved instance pricing. Essentially, what you're buying is the framework. You're buying a medium instance that is a 1-year commit at heavy utilization value, or light, whatever you do as your little cocktail. You can then apply that pricing to whatever instance you're actually running. Now let's look at the EC2 instance types and performance. So it all starts from an AMI, an Amazon Machine Image, which is essentially a virtual hard drive, and you translate that into a running machine or a running instance of one of these types. This all comes straight from Amazon Web Services when you create a new one. So let me just show you EC2, you hit the running instances, launch instance. Now the beauty is once you pick your image that you want to use, they have a pretty good description next to these guys. So for instance, I look at T2 small, got a little pop out, you see the virtual CPUs, memory, EBS, that's the elastic block storage, essentially non-solid state disk, at least as it stands today. I'm sure by the time you see this, everything's changing all the time. I look at the last Amazon Web Services series I did, I'm like, good grief, the interface doesn't even look that way. It's like I'm looking at hippie clothing. I'm like, hey, it's not the 60s anymore. Anyway, so you can see all the different types right here. Now, that's awesome, and it gives you a kind of base feel, but when you're being asked on, say, an exam or something, what's an M3? Or why would I use a C3 and all that, and you don't have this beautiful menu sitting in front of you, or you just have it committed into memory, that's where it gets tough, right? So when you see, first off, T2. T2 is where almost everybody starts with Amazon Web Services. It includes the micro, small, and medium. Now notice, these are general purpose machines. They're hardware, or I should say virtual hardware requirements of CPU and memory will always be changing, but the essence of these is that they're burstable. That's the unique thing about T2 machines. T2 is not guaranteed. It's like you get the scraps of what's left over. You get them for a really great rate, and they work well, but you kind of, Amazon is over-provisioning things all the time. And burstable means that essentially you get kind of a flat line, not really guaranteed. That's why when you look at the guaranteed requirements, they're like, there really is no guarantee that you're going to get a certain level of service out of those. You kind of get what's left over. But they do make it burstable. So for instance, you've got an application on that micro server that needs CPU utilization or disk I/O or memory. It's going to boom, burst up and give you that ability and then slowly throttle it back down. That's why when you boot a Windows machine on a micros instance, it comes up pretty fast. It's like, that wasn't too bad. It's because you're living in the burst land, right? Burstville essentially of it. But as you start looking for consistent performance of that machine on any one of those general purpose levels, it's not going to be there, right? It's designed for a quick burst, we'll say a web server that gets hit with a bunch of traffic and then goes idle for a long time. M3 is the same thing as T2, except it's fixed. Essentially, when they say you get 2 CPUs, you get 2 CPUs. It's not going to be over-provisioned. It's going to be 2 CPUs that deliver consistent performance all the time. And that's where you can see the medium comes over, and that's the difference between picking a T2 medium, which is a little cheaper, than M3 medium, is because M3 is going to be fixed guaranteed values, and that goes into large, extra large, and 2x large. The rest of these that you see down the list are just niche purposes, meaning, do you need a virtual machine that is CPU intensive? Then go with a C3 dot large, X large, 2X large, and essentially that's where you go through, and as you pick your instances right here, so you see large, X large, you can see they're increasing in a major way the processors to 32 CPUs. Yes, you're gaining memory because Amazon's realizing, if you're using 32 processors, then you probably need a substantial amount of memory. But if you look down here at the R3 is memory optimized. You still got the CPUs, but now we've got 244 gigs of memory that they're dedicating to those extra large instances. Now, some of you might say, well, I could see doing more in my own environment, adding more than 244 gigs of RAM, which for me is a stretch. I'm like, wow, really? But I could see adding more. Remember, that's not the Amazon way. You haven't drank the Kool-Aid of Amazon, which is horizontal growth, not vertical growth. It's not about bigger, badder, better servers, although you can definitely get that in the Amazon world. The most bang for your buck is going to be where you go horizontal and do a bunch of smaller servers, which, like the bees with machine guns, their combined forces will create a massive computing presence for you, right? So C2, CPU intensive, that's where it is. G2, only one of those because really not that many people care about this. This is not a platform where you're going to go play World of Warcraft, right? You might run a World of Warcraft server from here, but it's not end user facing. So GPU intensive is essentially for applications that use graphic processing because it processes different than CPU. For example, mining Bitcoin, a big thing that we do here at CVT Nuggets, is best done using a graphic processor unit. You get a lot better results if you use a GPU rather than using just the computer's processor. So the video card, if you install a Bitcoin mining client, it has nothing to do with graphics. It's just the way that the graphics processor works is much more geared for Bitcoin mining because it processes the algorithms of Bitcoin much better than a normal standard CPU processor. R3, memory intensive. This is what I just showed you. Again, 5 different flavors right now of memory intensive machines. As you increase, just like we saw on the previous slide, you increase that. Now the storage optimize is where you get a lot of storage, but it is optimized for I/O, meaning there are some applications, a lot of databases, that just constantly are hitting the disk, hit, and needs a lot of the IOPS, a lot of I/O from them. That's where the I2 series, I2 dot large, X large, and 2X large, and so on, as you go through this. Now, I know some of you might look at this like I did when I first got into Amazon Web Services and been like, couldn't they, well, I don't get it. Why do they have large, X large, 2X large, 8X large? I mean, it seems odd. Like, why don't they have, like, build your own machine, right? BYOD, where you're building your own machine in the cloud. The reason why is, remember, these people buy into with reserved instances. So, for instance, they'll buy into an X large instance, which the processors and memory doesn't change for that 3-year term. They've bought into that instance type until that instance type finally expires. Well, in 3 years, a lot changes. You might have a lot more requirements that people are looking for. So rather than just upgrading the large and saying, well, the large used to be 2 CPUs or 4 CPUs or whatever it is, now it's 8. Instead of doing that, they say, okay, well, here's an X large so people can buy into that with a reserved instance. Now, someday, will they upgrade the large? I'm sure they will. Everything changes all the time. But a lot of that is based off of the purchasing reserved instances. I think I just had a great analogy hit me as I flipped to this slide. This is like puzzle pieces, right? Like, I have a bunch of young kids, and we use those board puzzles. You know, they're kind of like the square boards. You hit them on the table, and all the pieces fall out upside down. So before this nugget, if you were doing Amazon Web Services, it's like you hit it on the table, and you're staring at a bunch of upside-down pieces where you're like, you try and kind of put them together, and you can make something work, but it's not meant to be that way. This nugget turned them over. We turned over all these upside-down cardboard pieces, and you're like, oh, okay, I can see the colors, but it's not a solution, right? And it's not meant to be, because you have to put these puzzle pieces together for your organization or for your setup that you're doing your best practice design. So by combining the pricing models and the way that you use those with the instance types, you can come up with the best cocktail overall. Do I need, some spot instances of some I2 extra large devices just because those are going to be processing behind the scenes, but I can lose them? Okay, that would work for my environment. Plus the front end web servers, I bet you we can get by with some M3. Again, you just put all those puzzle pieces together to create the perfect fit. I hope this has been informative for you, and I'd like to thank you for viewing.